Good morning friends, I hope you are following the thermodynamic video lectures. Up to now we are completed three types of process, that is the isobaric process, isochoric process and isothermal process. Now we are entering into the adiabatic process. Adiabatic process is a somewhat lengthy process, that is why I am making the videos as a three parts. Please follow the videos. Let me start with adiabatic process. What does it mean by an adiabatic process? So, it is an thermodynamic process in which the total heat energy of the system must be maintained at constant. That means, in this process the total heat energy of the system is a constant value. So, if any process the total heat energy of the system is maintained constant, that process can be called it as a adiabatic process. If the total heat energy is a constant during the process, the initial energy of the system is equal to final energy of the system. Then what is the change in heat energy of the system in a process is equal to, that is equal to Q final minus Q initial is equal to, it will be 0. What is the conclusion here? The change in heat energy, the change of heat energy in a adiabatic process is must be equal to 0 because of Q is equal to always constant. To perform an adiabatic process, the thermodynamic system and thermodynamic container, in the thermodynamic system, the system must possess some of the conditions. So, the process must be have the sum of conditions, that condition can be called it as the essential conditions. So, what are the essential condition to do the adiabatic process means? The first essential condition means all walls of the container must be perfectly insulated walls. That walls can be called it as a adiabatic walls. Let us assume we are performing an adiabatic process. In this one, our process must be maintained with constant heat energy. So, that means we are not allowing any heat energy from the surrounding or to the system to surrounding or surrounding to system. This is not allowed. To block this flow of heat energy from the surrounding to system or system to surrounding, the walls must be a insulating walls. These insulating walls are named as a adiabatic walls. So, the adiabatic walls condition, the property of the adiabatic walls means they won't allow the heat flow from the surrounding to system or system to surrounding. Generally, in the thermodynamic system, the system will be surrounded with a container and also the movable piston. Here is the movable piston is also having the adiabatic wall, because of there is a possibility to transfer of heat energy from the piston to surrounding or surrounding to piston. That means all sides which is enclosed in the system, here is the ideal gas is there, that walls must be an adiabatic wall or insulating wall. This is the very important condition. But in general observation, in practical observation, any wall is not a perfectly insulating wall. That means if you maintain any type of wall, they must have the sum of the transfer of heat energy from the system to surrounding and surrounding to system. That means to get the perfectly adiabatic process, what is the another essential condition means? Let me go to the second essential condition. The system must be expand or compress suddenly. What is the important of here? The second essential condition means, as the walls are not a perfectly insulating walls, so they can have the possibility to transfer of heat energy from the system to surrounding or surrounding to system. Now, I am taking, here is the wall surroundings of this system, here is the movable piston. Now, even we are maintained with the perfectly insulating walls, there is a chance to transfer of heat energy from the system to surrounding and surrounding the system. To block this flow of heat energy, we need to perform the process suddenly. That means, so we are taking the to perform the process very less amount of time, very small short period of time. That means we are not providing a time to exchange the heat energy from system to surrounding or surrounding to system. These are the essential conditions. Repeating once again, the first essential condition is the walls must be perfectly insulating walls. The second essential must be the process must be done in rapid manner, that is nothing but suddenly we have to do the process. In adiabatic process, what is the equation of state for the adiabatic process? So there is a equation of state, special equation, that is equal to PV power gamma is equal to constant. This is the thermodynamic equation of state for the adiabatic process, where the gamma is equal to the ratio of the molar specific heat capacity of at constant pressure, molar specific heat capacity at constant value. It is the ratio of molar specific heat capacity at constant pressure to molar specific heat capacity at constant value. So this is call it as a adiabatic constant. Here is the P is the pressure of the system, V is the volume of the system. So we need to use this formula, this equation of state when the system is undergoes in a adiabatic process. Now the continuation class will be done in the next video. I hope you are following, if you are feel that these lectures are useful for your academics or any competitive exam, I am requesting you please subscribe our channel for the more videos. Thank you for your valuable support.